This video was brought to you by Indently.io, learning Python made simple. How's it going, everyone? In today's video, we're going to be going over 5 bad ideas in Python. Because as a lot of you may know, Python is one of the easiest languages to learn due to how easy it is to use, and you can do so much in Python. But there are still some things that can cause a lot of trouble in your scripts. So that's what we're going to be going over in today's video. Starting with one of the first bad ideas, and this is modifying a list while you are iterating through it. And for this example, imagine we have a list of cool channels that contains these string values: Carbera, Indently, Argent codes, and bool. Next, we're going to loop through these channels and perform some operations while we are looping through it. So for I and channel in enumerate channels, we're going to check first if the channel is equal to Indently, then we're going to type in channels.remove channel. And the reason we're removing Indently is because naming your own channel as a cool channel is ultra cringe. And below this, we're just going to print I and channel. Now watch what happens when we run this. When we actually run the script, we're going to end up with Carbera, Indently, and bool, even if we removed Indently from the channels. And we can even verify that we removed Indently from the channels by printing the channels under the for loop. And what you're going to notice is that Indently actually was removed from the list. So why did it appear in our for loop? Well, that's simply because we confused the for loop with our silly little operation here. The job of the for loop is to loop through each element in an iterable, and it starts with the index of 0, which at this point is Carbera, and then it moved to the index of 1, which happened to be Indently. And here we decided to remove Indently from the index of 1. But the for loop still thinks it successfully iterated through the index of 1. So then it moved on to the index of 2. But since we removed Indently, Argent codes was skipped because the for loop thinks it already looped through that element. And that's why when we run the script with Indently, it still prints Indently, even if we successfully removed it from the list. And this behavior's incredibly hard to debug. If you have thousands of elements, you're not even going to notice these silent changes or this unintended behavior. So all I'm trying to say is that the operation you're trying to perform might be a success. But if you're doing anything else in the for loop, it can lead to some unintended behavior in your script. And that behavior can be incredibly hard to debug. So one of my personal rules is to never modify a list or the original list while you are iterating through it. And to solve this problem, I recommend you work on a temporary copy. So you can even have a list called channels temp of type list of string, and then apply all the changes to the temporary list. And this will make you have to think outside the box in terms of your for loop, but at least you're not going to have to worry about that unexpected behavior that you got when you were iterating and modifying the original list. Moving on to bad idea number 2. And this has to do with encountering exceptions. And it might sound counterintuitive, but what if I told you that encountering exceptions was actually a good thing in programming? Well, that's actually the reality, at least during development. You want to encounter as many exceptions as possible so that when you push your app into production, it will hopefully be error-free. But the problem is that in Python, it's very easy to get lazy with exception handling. So let's go through a couple of examples. And first I'm going to import from typing the anytype. Now, first of all, we're going to get some user input of type string, or actually it's going to be of type any, and that's going to equal 10. The string of 10. And the reason I'm inserting any here is because I'm lazy with the type right here, is just to simulate that the user can actually insert anything here. Usually it's going to be a string, especially if you use the input command, but in this example they can insert anything. Now what we're going to do is try to convert the user input to a float. So we're going to print the f string of converting, and I'm going to use the escape sequence to insert user input in quotes to float. And then we can actually print the conversion. So converted is going to give this output, the float of user input. Otherwise, we're going to accept exception as E. And here we can just print the error with the error message. Now, when we run this, the program is going to work just fine. As soon as it encounters an error, it's going to print the error message that it could not convert string to float. 10. And we could understand that perfectly fine as a developer. But this is extremely lazy because right now we can actually insert any error. If we were to add none, it's going to create a type error. And that's going to give us a different error message. But there's nothing that says a developer is either lazy or doesn't know what they're doing as accepting exception as E, because now you're trying to accept every exception or everything that can go wrong in one exception block, which for a quick script might be okay, but if you actually want to create a serious program, it's good to understand exactly what can go wrong. And if something unexpected goes wrong, it's good to encounter that exception as soon as possible so that you can handle it correctly. In this case, the two major exceptions you can encounter with trying to convert user input to a float is the type error and the value error. Either you insert the wrong type or you insert a value that doesn't make sense, such as the string of 10. A string is an accepted type, so that's going to work, but the value doesn't make sense because it's written in English. So what we're going to do instead actually is accept type error as E, and here we can print, enter a valid number. And under that we can accept value error. Please enter a number in the form of digits. So now we're handling each one of the exceptions properly, which means when we run this, we're going to get a personalized message that handles it specifically. I mean, right here, I'm just printing what we did wrong, so it's not really handling anything, but we're handling those exceptions explicitly, which is the sign of a professional Python developer. And if we enter, let's say, none, it's going to ask us to enter a valid number. And obviously you can also group these, so you can type in type error and value error if you want to handle them on the same block, because you might consider these to be the same thing. And then behind that we can print the error message, so we can tell which one of these it actually is. So now if we run this, we're going to get please enter a valid number. Float argument must be a string or a real number, not none type. And if we change this to 10, we're going to get that value error. So we're going to get a different message. And in the case we only handled one error, you'll notice that we're actually going to explicitly encounter that value error, which makes it very easy to notice that we did something wrong and to fix it immediately during development. So try to be as explicit as possible with the errors you can encounter. And the best way to learn about all of the errors in Python is to encounter them. So look for a list online of all the possible errors that you can encounter on Python and try to reproduce them so that you actually learn how Python works. For example, you might find out that there's something called a name error. So here we're going to type in 10 user input. As soon as you run that, you'll notice that this is not a name error. It's actually a syntax error because you can't have a number in front of a variable name. So what I was trying to do actually is print X. This is going to result in a name error because name is not defined, or name X is not defined. As a professional Python developer, I can reproduce practically any error on purpose. And if you're learning Python, I highly recommend you learn to do the same. It just makes it so much easier to debug when you know exactly how an error is produced. Up next, we have bad idea number 3. And this has to do with endless if-else checks, which is something that's quite easy to avoid. But let's get started by creating the bad example. So we're going to have a function that's called check all. I'm going to make this slightly smaller, but we're going to check whether the user has money, which will be of type Boolean, then whether the user has time, which will be of type Boolean, whether the user has a girlfriend, which will be of type Boolean, and this check's getting quite long. And finally, we're going to check whether the user has a cat, which will be of type Boolean. And this function is going to return a Boolean. And this function might already be handling too much, but pretend you have a function such as this one that has to check 4 Boolean values. For example, for this function to work, we're going to check if the user has money, and if the user has money, we can check if the user has time, if the user has a girlfriend, and if the user has a cat. And actually, this is taking a lot of lines, so I'm going to just tap on enter here and make this bigger. So as you can see here, we have 4 checks. And you might be asking, why aren't we just chaining this in the simple if has money or has time and has money and has girlfriend? Why are we not chaining it like this? Well, the answer is because we want to handle each one of these cases separately. And by doing this, we can only handle it all at once. So in this example, it's important that we actually nest it so that at the bottom we can type in you have everything because we have money, time, a girlfriend, and a cat. And we can return true. Now this is where it starts to become annoying because we need to handle the else cases. So we're going to print no cat under the no cat block and return false. Then we need to remember to unindent and add another else block and print no girlfriend and return false because we want to make sure that all of these conditions are true. Then we need to unindent one more time, and I spelled else in the most incredible way. So else we're going to print no time and return false. And you can probably already see why this is a bad idea. We've already lost sight of which if block we're working on. I mean, of course, I've magnified my screen, but even if we zoom out, it starts to get really messy. And we still have one more. And here we need to print no money and return false. And if we actually run this, we can print check all. Has money can be set to true. True. Has girlfriend can be set to false. And we can set cat to true, why not? And when we run this, we're going to get the output that we have no girlfriend. And if we add true there, it's going to say we have everything because all of these are true. So the function works as expected. But once again, having to keep track of all these else blocks can be quite annoying because it's very easy to unindent one of these and just put them in the wrong place. I mean, you're going to get some error messages, of course, but pretend there's actually a case you don't want to handle, such as you don't really care about handling if has time, but you still want to keep it there. We're going to have this weird skip. So all I'm trying to say is that nesting if else blocks is okay to a certain extent. But once you start having to do it for 3 or even 4 times, it starts to become unmanageable. So what I'm going to be showing you is a good alternative to this, so that you don't have to spend all your time keeping track of the indentation level. And again, if you don't care about handling all the else cases, you can easily just combine the check in one expression using AND, or even using the all function. But now I'm going to be showing you a much more maintainable way of achieving the same thing. And to do this, we're going to remove this ugly code. And what we're going to start with is if not has money. So now we're doing this backwards. We're creating what they call a guard clause. And here we can print no money and return false. And now we can copy this, paste it under and check if has time. Or if not has time, we can type in no time. And we're going to do it for the other two as well. And I really can't see this, so I'm going to actually unindent this back so that when we go down, I can still see it. If not has girlfriend, no girlfriend. If not has cat, no cat. Otherwise, at the bottom, we can print you have everything. And we can return true. And just like that, we're going to get the exact same output, except we did it in a different way. We achieved this using the guard clause. And if we change this to false, we're still going to get that personalized output, or that custom functionality, when we encounter an expression that returns false. And the benefit of doing this is that we don't have to keep track of all of those indentation levels. It's very clear where we're using the block and where the code belongs, so we don't have to worry about indentation level. But at the end of the day, it's up to you how many indentation levels you find clean or messy. Personally, once it hits 3, I find it to be quite messy and unmanageable because I make a lot of mistakes, especially when it comes to indentation levels. And this is an exaggerated use case, but it's still good to know about if you want to keep your code maintainable. Moving on, we're going to be talking about recursion and why it can be a very bad idea sometimes. And I mean, recursion might seem to be an attractive option when you're programming because it's very easy to do. It's important though that you always calculate how often you think you're going to use a function before you opt in for recursion, because function calls are expensive. And with recursion, you can end up with a program that will become unnecessarily slow. And we're not even talking about optimizing here. There are just some moments you should absolutely avoid using recursion. And the best way to demonstrate it is to create a function that calculates the next number in the Fibonacci sequence. So here we're going to create something called Fibonacci, and we're going to call this recursive. It's going to take a number of type integer, and it's going to return to us an integer. Then inside here, if n less than or equal to 1, then we will return n. Else we're going to use the recursive approach on this function. So Fibonacci recursive n minus 1 plus Fibonacci recursive n minus 2. What are you complaining about? Missing return statement. That's very true. We are missing the return here. Thank you, MyPy. Anyway, let's test this out by typing in Fibonacci recursive and passing in 10. And when we run this, we should get the 10th number in the Fibonacci sequence, which is 55. But before we move on with this, I want to create a function that times other functions so we can see how long this actually takes. So here I'm going to paste in this function, and I'm going to explain what it does in just a moment. But before we continue, I need to import, or from typing, I need to import the callable type, and I need to import time. Anyway, here I have a function called time function, and what it takes as an argument is a callable, which can be any function that takes an integer as an argument and returns an integer. Then we have n, which is the number we want to pass into our Fibonacci sequence. And this returns none because we're only going to be printing information. Next, I created a variable called start time, which gets the current time using the performance counter provided by the time module. And the result is going to be the result of the function that we call with n. So essentially, we're just going to pass in Fibonacci recursive here. And then we need to grab the n time. So I'm going to assign this performance counter to the n time, and I'm going to display that information here. The function name with the argument and the result, and then the total time that took. Anyway, with this time function, we can go down here and we can type in time function. We can pass in Fibonacci recursive. And then as the argument, we're going to pass in 10 once again. Or to be fair, it doesn't return anything, so we're just going to call it as it is. So that the next time we run this, we should get the result, the function name, and the amount of time it took. If we add 20 here, it's going to take a bit longer. If we add 30 here, it's going to take a bit longer. If we add 35, it's going to take a second, an entire second, only to calculate the 35th number in the Fibonacci sequence. And that's actually very slow. That should raise a red flag in your mind that you should not be using recursion here because it's unnecessarily slow. In cases like this, you should opt in for the math approach. So now we're going to create the same thing without recursion. So Fibonacci, it takes n of type integer, returns an integer, just like the previous one. And here we're going to do AB equals 0, 1. Then for underscore in range of n, we're going to do the math of Fibonacci. So A, B equals B, A plus B. And then we can return A. This is the basic code we need to actually calculate Fibonacci. But next, let's try to time this function. So right below the recursive call, we're going to try the regular one. And when we run this, it's going to take a second for the recursive one. And then it's going to take essentially 0 seconds for the one that does not use recursion. And I'm actually going to switch the place of these two because we want to see the fast result first. And I can even insert 100 here and it's going to calculate it instantly. While if we were to do that with the recursive option, that's not going to appear for maybe a couple of minutes. And that's because we picked the wrong place to use recursion. Now, with all of this being said, it's not wrong to use recursion. For example, if you ask a user for inputs and they insert something and what they insert raises an error, you might want to handle that error by telling them they are drunk and need to insert something that the program can actually understand. And then recall the same function that asks for user input inside the except block. That's a good place for recursion. And just to show you real quickly, we can create a function called doMath and it's going to return none. Then we're going to print, please enter a number for A and B. Then below that, we can try to grab A, which will be of type float, and that's going to equal the float of the input of A, colon space. We will duplicate that and try to grab a value for B from the user. And finally, we will print that the sum of A plus B is A plus B. And in the except block, we're going to accept the value error and the type error, and that actually should be in parentheses. And we're going to print, mate, I said a number, not a vegetable. Please enter only valid numbers. And finally, we can perform recursion here. And this would be an ideal place to use recursion because we are waiting on user input. We're not trying to call this function immediately a million times. Which means that when we run this, we can enter something such as this random text, and that's going to raise an exception, which is going to lead us to the recursive call of do math, which means we need to enter a again. So here we can add 10 and 20 and then it will work fine. But that did not affect the performance of our program. So that's a great example of where you should use recursion. So just make sure that when you opt in for recursion, that you know exactly how often you're going to call a certain function, because that's going to be a crucial factor for the performance of your program. And finally, it's time we discuss why you should never use mutable default arguments in Python. And to get started, we're going to create a function called add_to_list, which is going to be one of the most popular examples you will see when trying to understand this concept. And that's going to take a number of type integer, and then we need to specify a target list, which will be a list of type integer. And if the user does not provide this list, we're going to have a default set to an empty list. And most intelligent code editors are going to tell you not to do this, or they're going to warn that this default argument is mutable. And it's not illegal, but it's something you should avoid. Unless you know exactly what you're doing, then you can keep it there. But I'm going to show you why it can be a bad idea. And this is going to return to us a list of integer. Now inside here, we're going to type in target list, append, and the number we want to append to it. And finally, we can return the target list. Next, let's test it. So we're going to create some numbers of type list of integer. That's going to equal 1, 2, and 3. Then we're going to print add to list 10 to numbers. And then we will copy that and add 20 to numbers. And when we run it, it's going to work perfectly fine. The first time we append 10 to that list, we're going to have 10 inside that list. And then when we append 20, we're going to have 20 inside the list along with 10. So the function's working quite fine when we provide a list that we've created. But now watch what happens when we do not provide a target list. So here we're going to type in first, which will be a list of type integer. And that's going to equal add to list 1. Then we can print first. And what you're going to notice is that the list is going to contain 1 as an element. And that makes sense. But next, let's create another list of type integer, which will equal add to list 2. Then let's print second. Now, when we run this, you're going to notice that list 2 contains the value of 1. And that is unintended behavior, because here we expected to create a completely new list. Also, if we were to print the first list, you're going to notice that the first list also contains the value of 2. And this is unintended behavior because each one of these lists should be independent of each other. This list should only contain the value of 2, and this list should only contain the value of 1. Instead, we got two lists that share the elements. So, why is this happening to our program? Well, the reason is right here. We gave target list the default argument of an empty list, which is a mutable data type. And what that means is that once we run our script and this function gets created, it also creates target list as a variable and it gives it this reference type, which means really right here, we only have one instance of this target list. It created this theoretically as a variable. Every time we run this function, it always referred to the list it created once. It doesn't recreate this every time we create the function. It only creates this once. And I'm going to remove this line here, but you can verify that by printing the ID of the first list and the ID of the second list. You're going to notice that they're going to share the exact same ID because each time we run this function, we refer to the exact same mutable default argument. So just keep in mind that when the function is defined, this is only created once when it comes to mutable default arguments. But now let's look at how we can fix this problem. And it's actually quite simple. First, I'm going to zoom out and we're going to have to make this an optional type. So the target list can either be a list of type integer provided by the user or none. And the default argument will be set to none. And we can actually make this bigger again. Then inside here, we can remove all of that. And what we're going to do is check if the target list is not none, then we can type in target list.append n. Else, target list is going to equal a list with n. So here we're actually creating a new list inside the function, which is completely different than creating it in the function signature, because this will be run each time we run the function, while when we did it here, it was only run when we created the function. Then at the bottom, all we need to do is return the target list. And thanks to this little change, the next time we actually run our script with first and second, we will get two separate lists because now Python understands exactly what we want to do. We want to create a whole new list each time we don't insert the list as an argument. So I hope that helps explain why you should never use mutable default arguments in your functions. Anyway, that's really everything I wanted to cover in today's video. Do let me know in the comment section down below whether you have any other bad ideas when it comes to programming in Python. But otherwise, with all that being said, as always, thanks for watching and I'll see you in the next video.